Welcome back to the 4.6 notes video. This one is going to be about solving polynomial equations. I am not really covering anything brand new today. Everything we're doing today you've seen before. There is a little bit of terminology. Solutions are the same thing as zeros, are the same things as x-intercepts, are the same things as roots. They're all the same thing. I'm going to use the word roots a lot. These are the same things as zeros. They're also just the solutions, okay? We will find these solutions, or zeros, by factoring completely. We've already learned how to factor completely. We did it before winter break. We're just going to learn how to take the next step and actually use the factors to find the solutions. I did include this little flowchart for you. When you're trying to decide how to factor, it's all based off of how many terms there are. But before you get there, you always have to look for the greatest common factor first. Then you're going to see if there's 2 terms, 3 terms, or 4 terms. If there's 2 terms, really your only option here is going to be difference of squares. This is where it's 2 perfect squares being subtracted. If that's not possible, then it's probably already factored or it's not factorable. So if there's 3 terms, you have a trinomial. That's what 3 means, is tri. And this is where you want to multiply to the last number and add to the middle number. So you want to find the 2 numbers that multiply to the last and add to the middle. If there is a number in front, that's what this means. A not equal to 1 means there's a number in front like this. Okay, we're saying that A is the leading coefficient because it goes like A, B, C, D, etc. If there is a number in front, you want to multiply to the first number times the last number and add to the middle. And then underneath this, I'm going to write split, because then you have to split it up in the middle and you're going to move into this type of factoring. Grouping is the easiest one to identify because it's the only one that looks really long and it has 4 terms. Sorry, that was a little blurry. Okay, so these, you'll notice all 3 of these have 4 terms, so we're going to group. When you are grouping, just a reminder, you're looking at these first 2 together and the second 2 together. And you want to take out their GCF. Now, check the whole thing first. There's nothing that goes into 2, 5, 6, and 15. There's also not an x on all of them. So you don't have a greatest common factor over the whole thing. What I'm going to do here is take out an x squared as the greatest common factor. And when I say take out, I mean divide. So 2x cubed divided by x squared is just 2x. It takes a power of 2 away from the cubed. 5x squared divided by x squared, the x squareds cancel and it's just 5. And then we have negative 6x and negative 15. 3 goes into both of those. And you don't want the first thing in the parentheses to be negative, so you're going to take out negative 3. Negative 6x divided by negative 3 is 2x. 2 negatives divide to a positive. Negative 15 divided by negative 3 is positive 5. And then you'll notice that there's the same parentheses here and here. That's your first factor. And the other factor is what's on the outside. X squared and negative 3. And then we want to set both of these equal to 0. 2x plus 5 equals 0. Now, normally we didn't write this all the way out. I am doing it this time just to kind of be very, very clear with you. If I wanted to solve this equation, I would subtract the 5 to the other side, giving me 2x equals negative 5. Divide by 2. Negative 5 halves is my first 0. Over here, I would add the 3 to the other side and take the square root. So it's like solving for x, but at the very end you do the square root to cancel out the squared. And when you do that square root, the square root of 3 is not anything except for the square root of 3, but you also have to add negative square root of 3. Because whenever you square root both sides, you need the positive and the negative version. And you'll count up your zeros. You have 1, 2, 3 of them because you had a power of 3 up here. This power, the highest power, should always match how many zeros there are. Then we're going to move on to the next one. Over here, first of all, nothing goes into 3 and 2, and not all of them have an x. But between these two, I can take out an x squared, which takes away a power of 2 on both of them, leaving this one as a power of 1, so just 3x to the first, and this x squared will cancel out, so it's just negative 2. And then over here, we can divide these both by 4. And since this is negative, you actually want it to be negative 4. Negative 12 divided by negative 4 is positive 3. Leave the x. 8 divided by negative 4 is negative 2. The two parentheses match, so it's 3x minus 2, and the outsides are x squared and negative 4. And we're not quite done yet because this has 2 terms and this has 2 terms, just like these two did. The only way to factor 2 terms is if it's a difference of squares, which this one is. I didn't stop and ask about it on this one because it already wasn't, and so we didn't have to do anything with it. This is the same thing as x plus 2, x minus 2. If you have 2 perfect squares being subtracted, you do the square root of the first one, the square root of the second one, and you put a plus and a minus in between them. Don't forget the one that was already out front. Then this one is going to end up being, you would add the 2 and divide by 3 if you had it equal to 0. This one you would subtract the 2, leaving it to be negative 2. And on this one you would add the 2, leaving it to be 2. And we have 1, 2, 3 zeros, and look at that, it had a power of 3 up here. All right, on this last one, these all do have an x. So I'm going to take an x and put it over here outside the parentheses. And then everything is going to lose a power of x, leaving the 10 without an x at all. Then we have to factor what's left inside by grouping. Hey, here you can take out an x squared. Notice how we did that on all 3 of these. That's always going to be how grouping starts. And that's going to leave me with x minus 2. Over here, I can divide these both by 5, and since the one in the middle is negative, you want to take out negative 5. Leaving me with x minus 2. So I have 2 factors, x minus 2 and x squared minus 5, from this parentheses right here. Now, I'm going to finish out the problem, and I'm purposely leaving off something really small that I'm going to add in just a second. If you see what it is that I'm missing, I will fix it in a second. I'm going to go ahead and finish up with these though. So this one would be 2, just like it was over here. It's always going to be the opposite of what it was in parentheses. And on this one, you would add the 5, and x squared would equal 5. So then you go do the square root on both sides, and you get the square root of 5 and negative square root of 5. Now, let's go double check our zeros. I have 1, 2, 3. But my power was 4. I should have 4 zeros. None of these showed up twice, so there's not a double root. What's missing? This guy. This x that I kind of left off right here. So it should have stayed outside like this whole time. But I usually don't write it on this step because there's already so many parentheses going on. I usually just put it back here. Now, this x out front doesn't have a number being added or subtracted. If you set this equal to 0, it'll just be x equals 0. That is your fourth missing zero. Okay, let's move on to some trinomials. So here, we want to subtract this 6x so that it's on this side. So I'm actually just going to turn this into a minus sign and set it equal to 0. And all of these have an x, meaning I can take out an x in front of the parentheses, just like I did on the last problem. And it just takes up everything down by a power. And then just like I said up here, if there's no number in front, or if it's a 1, just like there's a 1 in front of this x squared technically, then you're going to find the two numbers that multiply to the last and add to the middle. So what multiplies to -6 and adds to 1? Well, that would be 3 and -2. And that's the factors. So I've got 0, -3, and +2. And that's 1, 2, 3 zeros. And look at that, it started with a power of 3. On the next one, you'll notice that there is a number in front. If there is a number in front, see if it goes into all of these. And it does. So I'm actually going to take out a 2x instead of just x like I did on this one. That's going to take everything down by a power of x and divide everything by 2. Like that. And now there isn't a number in front, so I can again find the two numbers that multiply to 12 and add to -7, which is -3 and -4, leaving me with zeros at 0, 3, and -4. Now I'm going to go back and kind of talk about this one for just a second. Some people are like, but there's a 2 there this time. If you wanted 2x to equal 0, you would divide by 2, and 0 divided by 2 is just simply 0 still. So really, essentially, that 2 doesn't do a whole lot. It's really the same thing as this. And on the last one, 2 goes into all of these. So guess what? You're going to take out a 2x again. Right? The first thing I'm going to do this time is just divide by 2. I'm going to get 1, -6, and 9. And then I'm going to take a power of x away. This is going to become x squared. This is going to become x. And this x is going to go away. And then I have to find the two numbers that multiply to 9 and add to -6. Well, 3 and 3 are really the only numbers that go into 9. And I want them both to be negative so that they add to -6. And then I have zeros at 0 and 3 and 3 again. So another way of writing this would be 0 and 3, which is a double. And that's what it looks like when you get a double root when you're factoring. Sorry, I forgot to box my last answers over there. Okay, what we're going to do on the last page is we're going to find the zeros just like we did on the first page, but then we're going to sketch a graph. Okay, so notice how these aren't equal to 0 this time. It's saying find the zeros, so that's the same thing as telling you to set it equal to 0. Okay, so let's fix this a little bit. I can divide all of these by 3. 3 divided by 3 is 1, x to the 4th. -6 divided by 3 is -2, x squared. And 3 divided by 3 is 1. Now, even though the powers are a little different, we're still going to find the two numbers that multiply to 1 and add to -2. Those two numbers are going to be -1 and -1. Because -1 plus -1 is -2, and -1 times -1 is 1. I know, that one's kind of tricky. Then, the term that's going to go right here is whatever was in the middle. So instead of x, it's just going to be x squared. And we called this factoring in quadratic form before. Okay, and you'll notice, hey, look, those are the exact same. That's okay, we're going to keep going because this is a difference of squares. Okay, which means that I can make it x plus 1, x minus 1. But I can do the same thing over here. I'm going to leave that 3 out front. This 3 is not a 0 because 3 doesn't equal 0 and there's no x with it. So this does nothing for us. But we've got negative 1, 1, negative 1, 1, which means my zeros are negative 1, which is a double, because there's 2 of them, and 1, which is also a double. So that's 1, 2, 3, 4, 4 roots, because I had a power of 4. All right, then we have to sketch a graph of this one. So what we're going to do is draw our little graph. I'm going to put a point at negative 1 and 1. And then I'm going to draw my graph. There was a positive 3 out front, and there's a positive 3 out front of the factors. So that means it's going to go up on the right side. But these are all double roots, so it doesn't go all the way through, it goes back up. And then it's going to head towards the next one, and it doesn't go all the way through, it goes back up. And there you have it. Over here, I'm going to take out a negative 2 on all of these. I'm going to divide them all by negative 2, which leaves me with x to the 4th, negative 8, x squared, and positive 16. We're just dividing these all by negative 2. Powers aren't changing. Now, I need two numbers that multiply to 16 and add to negative 8. Well, that's going to be negative 4 and negative 4. So I get kind of a similar thing to the last one. Because this is x squared in the middle, that's why I'm leaving these as x squareds. Okay. Then, that's difference of squares again. Because 4 is a perfect square, its square root is 2. So I have x plus 2, x minus 2. X plus 2, x minus 2. And don't forget that there's this negative 2 out here. There's a lot of 2's going on in this problem. Now, this one is not a 0 because it doesn't have an x. It has to have an x to become a 0. This one's going to be negative 2. It's always the opposite of what's in the parentheses. So I've got two negative 2's. So negative 2 is a double. And 2 is a double. So when I go to draw my graph, I'm going to put a point at negative 2 and a point at 2. Now, this one has a negative out front and a negative out front. So that means the right side goes down. And the same thing's going to happen where this can't go all the way through because it's a double root. So it's going to come back down, going to come up over here, and go back down. And last but not least, we're going to divide everything by 4, leaving us with x squared minus 10x squared, x to the 4th minus 9. So I need two numbers that multiply to negative 9 and add to negative 10. And I'm actually going to go ahead and say that this was supposed to be a plus. Sorry, guys. Because those two numbers should be negative 9 and negative 1. So fix that little typo with me right there. And then this is a difference of squares. This one is 3, so it'd be x plus 3, x minus 3. This one is 1, so that'd be x plus 1, x minus 1. The 4 does not have an x with it, so it's not a 0. So I have zeros at -3, 3, -1, and 1. That's 4 different zeros. None of them are doubles this time. So I'm going to put a point at -3 and 3, -1 and 1. There was a +4 out front, so it's going to go up on the right side. None of these are doubles, so it's going to go straight through, straight through, straight through, straight through. That's it. And then the very last part says, write the equation of a polynomial with zeros of 1/2, 3, and -3. The 1/2 is a little tricky because you could write it as this, because it's always going to be the opposite from the parentheses to the 0. But a better way of writing this would be to multiply that by 2 and writing it like this. Because 2 times x is 2x. 2 times -1/2 is -1. That way, you don't have any fractions. Okay, so always multiply by whatever's on the bottom so that it doesn't have a fraction anymore. Okay, this one becomes the opposite. This one becomes the opposite. And then we just need to multiply these together. Okay, pick any two to multiply together first. I'm going to be really honest with you. If you notice that two of them are the same thing, just different signs, pick those together, go together first. So over here to the side, I'm going to do x minus 3 times x plus 3. Using the little box method that we used before, that's x squared, 3x, -3x, and -9. And the reason why I said if you notice that any of them are the same thing but opposite signs, those are conjugates. These cross out in the middle. So it's just x squared minus 9. And then we have to take that and multiply it by this. This time I will not use the box method so you can see a little bit of both. 2x times x squared is 2x cubed. 2x times -9 is -18x. -1 times x squared is -x squared. And -1 times -9 is +9. And then when I write it down here as my answer, I have to put them in order. So this needs to go before the x, because it has to go highest to lowest powers. And that's it.